Well, good evening, ladies and gentlemen. As the Vice-Chancellor said, it's 150 years since Queen Victoria bestowed a Regius Chair of Engineering on the university here in Edinburgh. And I'm just so delighted to be with you tonight to celebrate this landmark anniversary. And it's a real honour to be invited to give the first Regius Engineering lecture at the start of Engineering 150 celebrations. And as you've heard, my theme for this evening is the power of education, research, and innovation. So I thought I'd start by looking at some of the engineering developments that have originated at the University of Edinburgh. I would say the school's most famous alumnus really has to be the other Robert Stevenson, who spent 6 months here in Edinburgh at the university before going on to Columbia for 3 years. In fact, I learnt today it was only 6 months because he failed his exams. That's not quite so clear in Wikipedia. But he went to Columbia to work for 3 years as a mining engineer. But fortunately, he came back and went on to develop the rocket, a steam locomotive that really just helped change transport forever. A less familiar name is Dorothy Buchanan, who graduated from Edinburgh in 1922 and became the first female member of the Institution of Civil Engineers in 1927. Her first job was with engineering consultants Dorman Long, and she worked as part of the design team for the Sydney Harbour Bridge. She later worked on both the Tyne Bridge in Newcastle and Lambeth Bridge in London. The 9th and current Regius Professor is Jason Rees, who became a Fellow of the Royal Academy of Engineering in 2011. He was also a finalist in the Mac Robert Award for Engineering Innovation in 2006 with Brinker Technology, and I remember it well. And this is a spin-out company that had developed sort of mechanical platelets that could seal links in pipelines, and of course was a great interest to the oil industry. But it's not just the professors that innovate. I met some of the undergraduates this afternoon and their design projects, and they're certainly innovating. And this is another example. This is Alexander Enoch, who is a Edinburgh engineering graduate whose 3D printed robot, Marty, and you see Alexander with Marty, several Martys there. It started out as an educational toy, but is now helping to pioneer a whole new class of cheap programmable robots. His company, Robotical, is enabling children to learn to code as they play with Marty. Such achievements don't spring from nowhere. Engineers must be encouraged and nurtured and inspired. And to develop the next generation of innovators, we've got to address the shortage of engineers. And that's one of the key strategic challenges that the Royal Academy of Engineering is working on. Education is the key to progress in any economy, and I don't think anyone here would dispute that. However, we still have such a long way to go to ensure that all young people have access to the right education and skills for them. And currently, not enough young people are given the opportunity to understand what engineers actually do and explore the breadth of modern engineering in a way that enables them to make informed career choices. Today, the Royal Academy of Engineering and Engineering UK have launched a new initiative aimed specifically at teenagers. It's called This is Engineering, and it's a digital communications campaign centered on a series of video clips that will be shared with teenagers on social media. It's been funded by companies who are keen to recruit more engineers to fill the myriad of jobs that they're generating. The videos highlight engineering careers in new and unexpected ways, and I'm just going to show one now. So meet Vinta from the European Space Agency.
When I was a 6-year-old girl, I saw an image of a woman in a spacesuit, Helen Sharman, the first British astronaut. And I think in that moment, I realized what I wanted to be. I'm a space operations engineer. It's really exciting to see something that I worked on being used on board the space station. To me, engineering means a way to make a difference. It's the amazing impact you can have on the world, but also on humanity itself.
As part of our research for this campaign, we asked young people where they look for careers advice. Over half those surveyed said they'd use search engines, and they'd rather use a search engine than ask their parents and teachers. The world of work is, of course, changing rapidly, presenting young people with new choices, but it poses challenges for parents and educators. Only 3% of children said they wanted to hear about their parents' jobs. Some 74% of parents say that their children should consider whether their future career is something that they're passionate about. But actually, only 35% of those parents said their own job involved something that they were passionate about as a teacher. But our message to young people through the This Is Engineering campaign is that engineering is behind a lot of things that they love in everyday life and popular culture, and therefore can offer a career for them doing something that they love. And the various clips start from different passion points, as the marketeers have called them, whether it's sport or fashion or just helping people, and then show how engineers with those interests are enjoying the work that they're doing. Engineering is, I think, without a doubt, a career people love. As part of a recent survey on generating inclusive cultures, we had a survey of 7,000 engineers. And of those, 77% said that they liked their job all the time, or most of the time. 77%. This is an amazing statistic because another survey, actually that one done a few years ago by Investors in People, found that of the general population, 60% of people don't like their job and want to change. So we know that engineering is a job that those in it get a lot of satisfaction. And in that same survey, 82% said that they would recommend a career as an engineer to their family members or close friends. But not everybody knows an engineer to have such a recommendation. I suppose, like many people, I was attracted to science and engineering at school by a really inspirational teacher, and I can still remember those lessons when I was about 9 or 10, and he would be able to explain how science underpins our lives and the things we take for granted every day, whether it was readily available electricity or domestic appliances. He'd bring things in and just explain how it worked. And the idea that we could do that and we could improve the things that make such a difference to people's lives was, to me, very inspirational. But if students are looking outside home and school for their information, then we've just got to move with the times. And the This Is Engineering video clips are aimed to allow young people to explore the breadth of engineering that they may not have known existed. And then after that, if they're interested, they connect digitally through to a wealth of careers tips on the Tomorrow's Engineers website. And there they can find more detailed information on different types of engineering and the qualifications they need to become an engineer and help to shape the future. Education is rather different now than it was in the Victorian era, as Robert Stevenson's career shows. Coming from a middle-class family, the son of an engineer, he could attend school, and he went to the Percy Street Academy in Newcastle. At the relatively late age of 15, he was apprenticed to the mining engineer Nicholas Wood, but left before completing his 3 years to help his father survey the Stockton and Darlington Railway before coming here to Edinburgh University, and as I said earlier, staying less than a year. Following the success of the rocket, Robert was appointed Chief Engineer of the London-Birmingham Railway in 1833 with a salary of £1,500 per annum, which must have been phenomenal at that time. And by 1850, he had been involved in the construction of a third of the country's railway system. At that time, even someone as successful as Stephenson essentially trained on the job, developing much of the theoretical foundation for his work himself as he went along. The railway pioneers were learning by trial and error how things have changed. The concept of university research as the basis of knowledge and wealth creation just didn't come to be recognized until well into the 20th century. Today's universities are at the cutting edge of innovation, and the university research is seen to be a key driver of our modern economy. It underpins the development of new technologies that can drive business growth and deliver social and economic benefits. Universities are hubs for the exchange of knowledge, and therefore the translation of research into products, processes, services, ideas, and policies that can positively influence the UK's future. But perhaps still, the most powerful impact of universities is the people they educate. Industry relies on universities to develop in their graduates the skills needed for a prosperous and productive future economy. At the Academy, we're privileged to support some of the brightest young engineers in the UK, whom we expect to be among the profession's future leaders. However, the sustainability of the profession is at risk if we don't do more to attract young people to join us. For engineering and more generally in STEM subjects, there's currently a serious shortage and a serious challenge to ensure that we have sufficiently skilled people for our advanced economy. At every stage of the skills supply pipeline, we lose vast swathes of young people who cannot or don't wish to continue with science and engineering. The reasons for this are partly structural, with issues such as shortages of teachers in maths, physics, and computing, or issues with the curricular qualifications and assessment, which can stifle interest rather than enthuse and inspire the next generation. But they're also partly about how engineering is perceived. The UK government shares this concern and has designated 2018 as the Year of Engineering to highlight the scale of opportunity that careers in engineering hold for young people in the UK. Ministers from across government are joining forces with engineers, industry experts, and hundreds of businesses to change perceptions of the industry. The This Is Engineering campaign forms a key part of this initiative. 2018 is also, of course, the Year of Young People in Scotland, providing a great opportunity to link up with the Year of Engineering to highlight the wonderful career opportunities that engineering has to offer. Higher education, in close collaboration with industry, plays a critical role in addressing this challenge, and the Academy has long championed industry engagement in teaching in higher education. Our Visiting Professors programme places senior industry leaders in university engineering departments to provide real engineering context and practical examples. The programme's been used to drive curriculum change. And we had, for example, visiting professors in design, sustainability, and more recently, innovation, far earlier than those appeared in the curriculum. And in fact, I believe those visiting professors with their view from business have really helped embed those topics in undergraduate courses. The Visiting Professor Programme also promotes active or experience-led learning approaches. Working together in teams on engineering projects develops students' enthusiasm for engineering and also enhances their communication and project management and creative design skills. I saw that in the students in Edinburgh today, and they were also telling me that on one of their projects, I think it was the Formula student, it was a visiting professor that was helping them with some of their more challenging aspects of the design. Those design and build projects really help developing graduates the skills needed for successful careers. And it all, at the heart, has an education system that engages and inspires. And that's why the Academy really welcomes the approach taken by Education Scotland with the Curriculum for Excellence. Of course, as with England, no one would disagree that ensuring high levels of knowledge and understanding are crucial. But unlike England, the Curriculum for Excellence goes further with the application of the knowledge in multidisciplinary approaches to solving problems. That's really inspiring for young people, as well as preparing them to deal with the complex challenges of the 21st century. The decisions made at age 16 shape the direction for young people, and the Scottish Government's Opportunity for All is an important message that young people will be supported to develop their skills after they leave school, regardless of the pathway they wish to take to employment. The simple structure of the Scottish Modern Apprenticeship Framework is really attractive and it's got much to commend it. And as in England, we work with the Institute for Apprenticeship and Technical Education, getting to grips with the form of the post-16 provision in England. I think there's a lot that can be learnt from the Scottish model. The UK government's plans for technical education are moving in the right direction, but work is needed to ensure that they result in the change we need. Lord Sainsbury's recent review of technical and professional education recommended the introduction of a new system of two-year T-levels. These will incorporate technical skills plus English and maths at GCSE level and a relevant 3-month work experience. And the Academy is providing independent advice on the development of the engineering and manufacturing T-level. It's an important piece of work which will shape engineering education for many years to come. Moving on to industrial strategy. Over the last decade, successive governments, including one, have become interested in the concept that the Academy has long championed, a modern industrial strategy. A well-developed strategy can set a framework through which business and government can partner to promote jobs and growth. Such an approach has become even more important following the referendum vote in 2016 to leave the European Union. The current government has adopted industrial strategy with enthusiasm, even incorporating it into the name of the Department for Business, Energy and Industrial Strategy. The government consulted extensively on industrial strategy over the past year, and all 38 organisations representing professional engineering in the UK, led by the Royal Academy, worked together to publish a comprehensive response to the government's early proposals. Published as a report, Engineering Economy That Works for All. It was informed by nearly 1,300 survey responses, as well as a series of 10 workshops around the UK. Coming together in this way, we actually represent 450,000 engineers. And when you can say to government ministers that this is the combined view of the bodies that represent that number of people who are forming such a key part of our economy, it really attracts their attention. Our key recommendations were around engineering skills and diversity, particularly the need to boost digital skills, increasing funding for research and development, and improving energy efficiency. And it was pleasing to see these addressed in the government's report, Building a Britain Fit for the Future, which lays out their plans for an industrial strategy. And on Monday this week, we were very pleased to host Greg Clark, the Secretary of State in the department that embays the department responsible for industrial strategy. He came to a round table in the Academy to discuss plans, progress, and implementation, and particularly the role of engineering in those implementation phases. A modern industrial strategy should provide a framework to align different parts of government, and particularly to lay out consistent long-term plans that give industry the confidence to invest. Inward investment will help drive productivity growth, but in order to attract it, we need to be competitive on energy costs, on infrastructure, as well as having a strong science and engineering base and highly skilled people. The industrial strategy focuses on productivity, identifying 5 foundations, which you can see on this slide here, aiming to grow innovation and to build businesses and prosperous communities across the UK. Developing skilled people is an essential part of the strategy, with government aiming to establish a technical education that rivals the best in the world. We're certainly not there yet. Throughout this process, there's been a reassuring emphasis on investing in research and innovation. There's no doubt that the UK's research base punches well above its weight. However, the UK invests a lower percentage of its GDP in research and development than most of our competitor countries, as shown on this slide here. As part of the industrial strategy, the government has committed to reach 2.4% of GDP investment in research and development by 2027. It's about 1.7 currently, with an aspiration in the longer term for 3%. This is a very welcome development, and it, if achieved, would place the UK in the top quartile of OECD countries. And it's something that the Academy, well, we've been calling for the 3%, as have many others for a long time. But we're seeing real steps towards it. In 2016, in the autumn statement, the government committed to investing an additional £4.7 billion in science innovation over a 4-year period as part of the National Productivity Investment Fund. By the 2020-21 spending period, this should mean an additional £2 billion in R&D per year. And since then, the government's committed extra funds, bringing the annual increase to £2.3 billion by 2021-22. But the 2.4% target cannot be achieved by public investment alone. The industrial strategy provides a framework for government and businesses to come together and to co-invest in the future. As part of the strategy, several sector deals have been announced in life sciences, construction, artificial intelligence, and the automotive sector, and there are more in the pipeline. Sector deals are on offer, and they're a call for sectors to self-organise, collaborate, and partner with government to invest in the future and drive increases in productivity, employment, innovation, and in skills. The engineering sector has a crucial role to play in all of these sectors, and indeed in others that will come in due course. The engineering sector is just crucial to turning any increase in research and development investment into innovations successful businesses, and well-paid jobs. I also believe, though, that research collaborations between universities and businesses are an effective way of ensuring that we don't just do the research in the UK, which we do, and we do very well, but we're also ready to be able to capture the potential from our excellent research base in terms of value generated in the country. Business-university research collaboration is something that I'm familiar with. Just over 3 years ago, I was invited by Greg Clark, when he was then Minister for Universities, Science and Cities, to undertake a review of business-university collaboration. There had already been several reviews on business-university collaboration, and the UK is generally perceived as a good place to do this. We rank about 4th in the world. So why did government commission another review? Well, the UK is home to a number of major corporates with global perspectives, many of whom engage with significant collaboration with UK universities. But there's a comparative lack of medium-sized companies. There's a healthy community of SMEs, a substantial number of whom are involved in the supply chains of the major corporates. Some of them are spin-outs from universities and heavily engaged with the university base, and there are startups. And then there are also lots of micro businesses which by and large don't carry out or commission research. My remit was to examine how businesses of all types and sizes could be encouraged to connect with the UK's excellent universities through strategic research partnerships that delivered benefits for both the collaborators and for the country as a whole. 3 years on, I can say that some specific recommendations from my review have been implemented, but just as importantly, really, in times of change, the findings of the review continue to inform government thinking. We analysed the REF impact case studies, examples of how university research had led to demonstrable impacts in order to determine the extent to which companies in different sectors were engaging in collaborative projects. This word cloud on the slide illustrates our findings, and the size of the names of the companies gives an indication of the number of mentions that they had in the impact case studies. What became clear is that some companies were cited over and over again, and the content of the impact case study showed that they had benefited materially, their businesses had benefited materially from those collaborations with universities. But other companies, sometimes even those of the same size and in the same sector, hardly got mentioned. Also, through the surveys we did and the consultation we had with universities, we found that in many cases, a single university would have several separate interactions with one company, led from different parts of the university, sometimes even doing related things. But there was no oversight of that, and this was meaning that opportunities to develop a long-term strategic partnership with industry may have been missed. This diagram, and I'm not expecting you to read the print on it, but just to get the impression of the complexity. This diagram tries to chart all the organizations involved in supporting business-university research collaboration. So these are mostly different government organizations, some regional and some at a national level. Many people in the business community told us that this complexity acts as a barrier to engagement by companies, especially smaller companies, and SMEs. It makes it extremely difficult for companies who don't currently collaborate with universities to work out how they might do so and how they might get some help towards funding a collaboration. And to such an extent that that complexity can put some of them off trying to engage altogether. So we recommended that government should try and reduce the complexity in the public support system wherever possible. Or if they can't reduce the complexity, they should at least try and hide the wiring from those seeking support. And by that we meant that it should be made easy for those seeking support, even if internally there was a more complex system. While there are many bodies that have a role in promoting innovation and UK business-university interaction, there's only one UK-wide state innovation agency, and that is Innovate UK. It plays a particularly important role in forming connections between industry and academia. And so I was extremely pleased that UK immediately embraced this challenge and implemented our recommendation. It now has a no wrong door approach, which ensures that no matter how a business first contacts them, they're directed quickly to the right support for them. And that message has really resonated in government. Of course, some elements of support are devolved matters, and it would be remiss of me here if I didn't acknowledge that. And in particular, I should mention Interface, which connects businesses in Scotland's higher education to Scotland's higher education and research institutes. It's undoubtedly necessary, and when I was conducting this review, I heard many times that Interface is an exemplar of good practice. From April this year, we'll have a new umbrella organisation working to support the research and innovation communities, the creation of UK Research and Innovation, or UKRI, combining the UK's 7 research councils with Innovate UK and Research England. It's an extremely significant change to the UK's research and innovation landscape. It's got the potential to transform the way businesses engage with UK research, including through implementing some of the recommendations from my review. UKRI poses an ideal opportunity to expand the no wrong door approach adopted by Innovate UK and to make it apply right across the whole of UKRI. This is something that John Kingman, the chair of UKRI, has said he wants to do. I've heard Mark Wolpert say the same, and I very much hope that they will both get on now and implement it. UKRI can also apply the forum for introducing more uniformity across existing programmes and schemes offered by the different councils. For example, CASE Awards, Collaborative Awards, in science and engineering, an easy starting route for an industrial collaboration with a university, but actually only being offered in, not being offered across all the research councils currently, and having very different rules across them. So things can be made much simpler if UKRI really succeeds in getting integration. Another significant change to the research and innovation landscape is the departure of Joe Johnson and the appointment of Sam Geimer to the role of Minister for Universities and Science. Joe achieved a lot in his tenure, including the establishment of the Teaching Excellence Framework, the TEF, setting the wheels in motion for the Knowledge Exchange Framework, the KEF, and formally establishing UKRI by ensuring the passage of the Higher Educational and Research Bill into an Act. REF 2021 is now looming large in the priorities of my academic colleagues, and I'm delighted to see that recommendations from my review have been influential. Most notably, the weighting given to impact will be increased from 20% to 25%, and REF 2021 will offer more flexibility to recognise staff who've moved from industry, which is one of the things that we felt was really important to encourage that mobility. because they will come in without a significant publication record. But perhaps the most significant change for the engineering community, and this was not part of my review, is the creation of a single unit of assessment for engineering rather than the 4 engineering UOAs that we had in REF 2014. In theory, a single UOA for engineering should allow emerging engineering disciplines and reflect the collaborative nature of engineering research and enable all that to be better captured. However, it's going to be such a large unit of assessment that really careful planning is going to be needed to ensure that excellent research receives the recognition that it deserves. Despite the welcome introduction of impact, there's always been a level of frustration in the engineering community that the REF does not capture the key role that universities play in supporting knowledge exchange or translation activities. However, the proposed development of the Knowledge Exchange Framework, the KEF, announced last year, does have the potential to change that. The KEF will benchmark how good universities are at sharing expertise, knowledge, and other assets for the benefit of the economy and society. While we don't know yet what funding will be linked to the KEF in England, and I'm aware that Scotland's got its own distinctive mechanism to distribute the University Innovation Fund, the KEF is a step towards increasing the recognition and participation in knowledge exchange, but there's still more work to do. Because a perception persists in the UK that academics who pursue collaborations with industry face particular difficulties. And many told us throughout the course of my review that they collaborate in spite of, rather than because of, their universities. We need to realize that research can be most useful and excellent. And I believe the culture in the UK is now starting to shift towards a greater appreciation of use-inspired research. And by that I mean research inspired by the challenges faced by users, whether in industry or elsewhere. And it's just as challenging as pure research, which is inspired by what other academics are doing. Collaboration underpins use-inspired research, and it's been a key feature of my own career. Some of my most rewarding and successful research activities have come from my interaction with industry. One project I ran had something like 30 industrial partners, very much contributing to the research of 40 people between Cambridge and MIT. Business university research collaboration has been very much at the heart of the Royal Academy of Engineering's programs for many years. And one of the best ways of encouraging collaboration is to improve the flow of people between academia and industry, and to give researchers, particularly at an early stage in their career, greater exposure to businesses through training and placements. The Academy actively supports this process by jointly funding its research posts with industry and by enabling researchers, including some of those at Edinburgh University, to work with industry mentors. One example is Dr. Graham Spinardi, who works here in Edinburgh at the university on integrating the technical and social aspects of fire safety expertise and engineering. We also offer industrial secondments for academics to spend 6 months working in industry, and that often leads to new collaborations. Another issue, though, is the universities have to ensure that their promotion criteria fully recognize and reflect those who achieve success in collaboration, and make sure that not only are those policies put into place, but they're communicated effectively to staff. And I'm delighted that a proportion of the increased R&D funding will go through the Industrial Strategy Challenge Fund to support industry-led multidisciplinary research and business academic collaboration. There is a tremendous drive and commitment to make collaboration happen in the UK, with appropriate and often catalytic public support and clear and effective policy frameworks, there's a great opportunity to translate this into substantial benefits for the individual researchers, for companies' productivity, and for the competitiveness as a whole. I just want to end by talking about one other way in which the Academy helps research and innovation come to fruition in the marketplace. Founded in 2013, our Enterprise Hub supports some of the UK's most promising engineering entrepreneurs, and those include Alexander Enoch, the Edinburgh University graduate with Marty that I talked about at the beginning of my talk. What's so special about our support actually isn't the money, but it's the Academy Fellows, who include some of the UK's most successful entrepreneurs and business leaders. They give their time freely to mentor these aspiring entrepreneurs, giving advice on such issues as dealing with investors, manufacturing supply chains, IP, and how to negotiate with their universities and scale up. Notably, we don't take a stake in the businesses we support, giving the entrepreneurs who are Hub members the freedom to grow their businesses to their full potential. We also offer carefully selected training, networking, and funding opportunities. This year will be the Hub's 5th anniversary, and just 5 years, we've supported 73 entrepreneurs in our Hub family, who between them have registered 57 companies, created 256 jobs, and raised over 60 million funding from external sources. And a nice statistic, over 90% are still trading. The Enterprise Hub has its own dedicated space, the Taylor Centre, in the 2 lower floors of the Academy, and it's a great location where entrepreneurs can work, collaborate, and develop their skills. And I'm no doubt that in due course, they will make a great contribution to the UK's future innovation centre, ecosystem. And these are just photos of some of our Hub members. So in conclusion, I've spoken tonight about the engineering heritage of the University of Edinburgh and the importance of education, including both vocational skills and higher education, to the future of the economy. I've also looked at the opportunities presented by an industrial strategy rooted in the ideas generated through world-class research undertaken in the UK's universities. Capturing value from our research base through innovation, translation, and commercialization is of huge importance. The government's industrial strategy must ensure that we can unlock the potential in our research base and deliver products and services of value to our economy and to society. University business collaboration enhances research and innovation to the benefit of both businesses and society and to the researchers, and I've no doubt that it will continue to be a strong driver for growth. But none of this will work without people. We need more engineers at all levels from all backgrounds. In this year of engineering, I hope you will join with us in sharing your work and inspiring more people to join the engineering profession, both now and in the future. Thank you.